So we get this idea of a trade-off. A trade-off is when I have to choose one thing, and by choosing one thing, I give up another. We express the trade-off in terms of opportunity cost. What did that trade-off cost you? Well, the opportunity cost. So let's look here real quickly, and let's just make some conclusions. So if I grow 40 carrots, we'll say carrots instead of kilos of carrots, just because it's easier. If I grow 40 carrots, I lose what? Okay, I lose 20 rocket. If I choose, and again, trade-off is about a choice. If I choose instead to grow 20 rocket, well then again I lose 40 carrots. This is useful. This gives us like a bit of a conversation to have. If I do the one thing, I lose the ability to do the other. But what if I want a combination? What if it doesn't have to be all carrots or all rocket? Well, then I need to start figuring out, okay, well then, I guess we could do halves. If I grow half of my carrots, then I lose the ability to grow half of my rocket. But it's probably easier to just do it in terms of one. Okay? So, when we do this, and just so you understand, the convention, whenever we talk about opportunity cost, it's always in terms of one. The opportunity cost of 1 kilo of carrots. The opportunity cost of 1 plane flight. The opportunity cost of 1 lap swam, or ran, or whatever. Okay? It's always in terms of one, and you express it in terms of the other good. So the opportunity cost of growing 20 rocket is 40 carrots. The opportunity cost of 40 carrots is 20 rockets, but we need to do it in ones. Okay? So let's go over here and do some math. So what we can say is we can say that 40 is equal to 20. Now again, don't go tell your math teachers this. Understand that we're talking about 40 kilos of carrots is equal to 20 kilos of rockets because they both represent 100% production on 1 hectare of land. So now we need to figure it out in terms of 1. So let's start with, what does 1 kilo of carrot cost me? So now we're saying 1/40th, so 1 out of 40 kilos, is equal, well, we don't know. That's our variable that we have to solve for. We can cross multiply and divide, so we're going to get 1 times 20 is equal to 40 times x. Obviously, this is just 20. We're going to divide both sides by 40. And x is equal to 1/2. In economics, we don't like fractions so much. We like numbers because you don't normally write, well, 1/2 of a dollar. You write 50 cents. Anyway, so x is equal to 0.5. All right? So now, if we go, okay, well, the opportunity cost, if I grow 1 kilo of carrots, I lose the ability to grow 0.5 rocket. Okay, let's solve it the other way. Go ahead and try to solve this on your own. So what's the opportunity cost of growing 1 rocket? And the answer is 2 carat. Now, just so you know, whenever we do this, if I had written this as 0.5, I'm sorry, 0.5 as a fraction, it would have been 1/2. The answer to the other one is always going to be the reciprocal of that, so 2/1. Okay? So that's, I mean, we don't need you to do work that is extra. As long as you know that one is always the reciprocal of the other, that's fine, if you can express it that way. Okay? So here we have our answer. Okay? So now we're to the understanding of every time I grow a carrot or a kilo of carrots, I give up half a kilo of rocket. Or, every time I grow 1 kilo of rocket, I give up the ability to grow 2 kilos of carrots. So now I have a price of each of these two goods, and it helps me in my decision making a little bit. So if I decide, hey, I'm going to need 5 kilos of rocket, I can go, okay, well 5 kilos of rocket is equal to 5 times 2, so I'm going to lose the ability to grow 10 kilos of carrots. So you see how that's maybe a bit more useful than talking about 40s and 20s. Okay, let's move on a touch. Okay, so now let's show this information on the PPC. We showed it mathematically, we understand it mathematically, let's see it on a graph. So what I've got here is carrots and rocket in a table, and again I've got our original information here. If I grow 40 carrots, I can't grow any rocket. If I grow 20 rocket, I can't grow any carrots. Starting here, so I'm using 100% of my land, this is my hectare of land right here, and all of it is being used for for carrots. So, if I say, okay, I'm going to take 1/4 of my land and devote it instead to growing rocket. Well, we can bring that other slide back, or we can remember that every carrot, right, was worth half of a rocket. So I lose 10 carrots, and I gain 10 divided by 2, 5 rocket. Or, we can go this way, and we can say, if I want to grow 5 rocket, every rocket costs me 2 carrots. So 5 times 2 is 10, and I would subtract that over here. Okay, so now we're here at the second row. Well, what if we decide that this is too much carrot still and not enough rocket? Well, now we could go to here, half of the field, and of course we could do little bits in between. I'm just showing some examples. So we could do little bits in between, and again, 10 rocket, right? Growing 10 rocket would cost me 10 times 2 carrots, so 40 minus 20, 10 times 2, is equal to 20, and on down. So, now we can show this on the graph. So let's go ahead and do this. Some of you guys did not set up your graphs well. Maybe I was a bit too cavalier in saying that you don't have to have the same scale or whatever. You do need to have an even scale. It's okay if your y-axis is longer than your x-axis or something like that, but you can't go like 5, 10, 100. Okay, it does need to be like, mathematically logical. Okay, so let's start here. If I grow 40 carrots, I can grow 0 rocket. We're going to call this point A. If I grow 30 carrots, now I can grow 5 rocket. So here. I am doing this from the side, so forgive me if I'm a little bit off. We'll call that point B. The next is 20 and 10. 10 and 15. And then our final point there. Okay, so those should all connect on a relatively straight line. I was a little bit off because, I'm doing it from the side here, but that's how it should look. So, if we're looking here, fix that one. If we're looking here, what we can say is this line, it represents a specifically even trade-off. Every time I grow 1 rocket, I lose 2 carrots, right? Every time I grow 1 rocket, so this would be 1 and then down to 38. Or, if I'm starting here, if we're at point E, and again, this is why you need to label points, because then you can actually say it. If we're at point E, making 20 rocket, if I choose to grow 1 carrot, well, the next point up the line would be 1, and I guess 19.5. Because every time I grow 1 carrot, I lose the ability to grow half a kilo of rocket. And by the way, you do note here that I put K for kilo. That's proper graph making. Okay, let's talk about a few things inside of here. We're saying this line represents 100% production. So no matter the case, 100% of the field is being used. It's either being used for carrot or for rocket to some degree or the other. But what if things don't work out very well? What if there's a drought? What if some of the people working on the field are lazy? What if a machine breaks down? What if there's a, some sort of bug that starts to kill the carrots or something like that? What we start to look at is this is what we call our potential on this graph. This is saying this would be 100%, where we're producing at 100%, we're using our resources at 100% of their value. Anything inside of that, well, really A, B, C, D, and E, any single point is our actual output, what we're actually doing. So this is our potential, and then point C might be, well, we've actually decided to produce 20 and 10. But more likely your actual output is going to fall somewhere inside of that curve, okay, inside of the PPC. So now I can look at this and go, okay, well, according to my graph, when I produce 20 carrots, I should be able to make 10 rocket. But it says here that I'm only making 8. Okay? So again, this gives me a place to talk about. At point F, we're not being as productive as we could be, because at point C, I'm able to produce the same amount of carrots without, produce the same amount of carrots and more rocket. What about growth? Okay, well, growth can look like two things. If I'm at point F, any movement towards the PPC, so if I went from point F to point G, that's growth. It's growth towards my potential. We can also look at the whole line, the whole PPC, shifting out. So if we had a PPC that looked like this, and now we would call that PPC2, that whole line is saying this is more production. Our potential has increased. So maybe it's fertilizer, maybe it's a better method, maybe it's a new tractor that, plows the fields better. I don't know. Maybe it's better management techniques. But something has changed and it has shifted the PPC curve that way. So for example, on the quiz, when I asked you about training versus non-training for the athletes, you should have shown, depending on how you set it up, this would be not training, and by training, they shifted their PPC out. Or you could have said, well, here they are training, and if they don't train, their PPC is going to shift in. So likewise on this, a PPC there would be an inward shift, and this would represent that somehow our potential has decreased. At every level, we can produce less than we could on one of these two other curves. So again, this would be probably a longer lasting thing, so maybe a long lasting famine, or all your machines break and you can't repair them, or anything like that. Okay. Anyhow, we'll talk more about that later on, but those are some important concepts on the PPC.